Orbital. An orbital is a three-dimensional region in space around the nucleus where there is a high probability of finding an electron. Quantum numbers. Each electron in an orbital of an atom has a set of 4 quantum numbers. Quantum numbers tell us where an electron is likely to be found. The 4 quantum numbers are principal quantum number n, angular momentum quantum number L, magnetic quantum number M, electron spin quantum number S. Principal quantum number n. The value of n determines the energy of an orbital and thereby the energy of the electron in that particular orbital. The principal quantum number have only integer values. N equals to 1, 2, 3 until infinity. The larger the value of n, the greater is the energy level and the farther it is located from the nucleus. As you can see, the size of orbital becomes bigger as the value of n increases. Angular momentum quantum number L, also referred to as the azimuthal quantum number or subsidiary quantum number, describes the shape of the atomic orbital that an electron occupies. The values of n determines which values of L are allowed. The allowed values of L are 0, 1, 2 until n minus 1, which means the lowest value is 0 and the highest is n minus 1. Each value of L corresponds to the type of orbital. If the value of L equals to 0, type of orbital is S and the orbital shape is spherical. When the value of L equals to 1, type of orbital is P and the orbital shape is dumbbell. When the value of L equals to 2, type of orbital is D and the orbital shape is cloverleaf. The relationship between N, L, and M is shown in the table. If n equals to 1, then L can only be 0 and M equals to 0. Orbitals 1s and the number of orbitals is 1. If n equals to 2, then L can be 0 or 1, giving rise to 2 subshells, 2s and 2p, of slightly different energy. So the number of orbitals 1 for 2s, 3 for 2p, and the total number of orbitals equals to 4. If n equals to 3, then L can be 0, 1, or 2. There are 3 subshells, 3s, 3p, 3d. 3s has 1 orbital, 3p has 3 orbital, 3d has 5 orbital. So the total number of the orbitals for n equals to 3 is 9. If n equals to 4, then L can be 0, 1, 2, or 3. There are 4 subshells, 4s, 4p, 4d, and 4f orbitals. For S has 1 orbital, for P has 3 orbitals, for D has 5 orbitals, and for F have 7 orbitals. So the total orbitals for N equals to 4 is 16. Magnetic quantum number M determines the orientation of orbitals in space. The permitted value of M depends on the value of L. It has integer values ranging from negative L to positive L. The number of M values indicates the number of orbitals in a subshell with a particular L value. For example, if the value of L equals to 2, the value of N equals to negative 2, negative 1, 0, positive 1, positive 2. There are 5 permitted values of M. Since there are 5 permitted values of M, therefore there are 5 orientations of d orbitals. So we have dyz, dxy, dxz, dx squared y squared, and dz squared. Last one is electron spin quantum number S. Electron spin quantum number determines the direction of spinning motions of an electron, either clockwise or anti-clockwise, which is spinning on its own axis as Earth does. The electron spin quantum number has a value of positive half or negative half.